Right, so here we have a gram to mole example. So in this case, for the same reaction, we're starting out with grams of copper oxide instead of moles of copper oxide. And we want to know how many moles of carbon and how many moles of carbon dioxide we're going to make. So how is this problem different? Well, again, we're starting with grams instead. So here we're going to start with our grams of our substance, and we want to know how many moles of a product we're going to make, right? So we need to first take the grams of our substance, convert it to moles, so that we can then use the reaction to then convert to moles of another substance. And sometimes people get confused with this and they just say, oh, I'll just convert my grams of substance to moles of my substance. Well, no, that's just converting the substance itself to moles, right? But we're using the reaction to then take the moles of the substance to convert to moles of another substance, right? So it's first grams to moles of it's your substance itself, right? That's this conversion. And then moles of that substance to moles of another substance using the mole ratio, a mole to mole, right? So it's actually two conversions, gram to mole, okay? So we start with our grams of our substance, right? 18.65 grams of CuO. And we're doing two problems, so I'm gonna write them both out while I'm doing each step, because the steps are very similar to each other, right? If I'm starting out with grams of CuO, then grams of CuO has to go on the bottom, right? For my first conversion factor. So what do I need? I need the molar mass. That's going to be grams per 1 mole of the substance. So 1 mole of CuO goes on top. So I need the periodic table to get my molar mass of my substance. So I need Cu times 1. I need O times 1. Well, I know that oxygen is 15.9994, and I think copper is 63.456, but let's look. 63.546. I'm glad I looked. 63.546. So my sig figs will end here. So let's add those up to get our molar mass for copper oxide. Copper 2 oxide. 6346 plus 5. Whoops, messed that up. 63.546 plus 15.9994. I get 79.5454 grams per mole. So that goes on the bottom for both of these. All right, that will get me to my moles of copper oxide. Now that I'm at moles of copper oxide, right, I'm at this point. Now I can use my chemical reaction, which needs to be balanced, right, to get from moles of one thing to moles of something else. And I balanced it in my other, so we need to balance it again. That was 2, 2, right? All right, so I already know that for the first problem, I need to get 2 moles of pure carbon. So if I need to get to carbon, moles of carbon is going to be on top. And then I have moles of copper oxide, so moles of copper oxide has to go on the bottom, so it cancels out. Copper oxide is 2 for every 1 carbon. And for the bottom one, I'm converting 2 moles of carbon dioxide. So that goes on top. And again, moles of copper oxide goes on the bottom, so it cancels out. And it's the same ratio. It's 2 to 1, right? So my answers, again, should be the same here, right? It's the same problem. So 18.65 divided by 79.5454 and divide by 2. We have 3 or 4 sig figs this time, right? 4. And if I do this to 4 sig figs, it is 0.1172 moles of carbon, 0.1172 moles of CO2. And I didn't plan for these to be identical, it just turns out that way. The ratios turned out to be the same. And sometimes you get lucky that way.